And we're live. Welcome. Welcome, ladies and gentlemen, to the 18th day of Advent of Code 2022. So, days 15 and 16, man, they were tough. Yesterday wasn't too bad. A bit of tough logic and a bit of maths for part 2, which killed my brain. So, hoping today is going to be a lovely little Sunday. But who knows, Eric can do anything he wants. Okay, so, I'm ready to enter my inputs. I'm also ready with my latte, which I'm almost done. So I should be full of energy, ready to go. And I'll see you after the time lapse. Right, that's part 1. Really nice and fast, really good. It was actually one page of the actual question was 1 page long, so I'm happy with that. So I'll copy my files over and I'll see you after the part 2 time lapse. Yeah, and that's part 2. Right, that took a very long time. I cut out a couple of minutes from the recording, just because I was expecting it to take even longer. But yeah, the recording's a bit shorter, but only a couple of minutes. Either way, still took me, I think, an hour to do this part. Yeah, anyway, I really like that problem. Yeah, I think we'll talk about it afterwards, but yeah, let's go on to the question. Day 18. Check I'm recording. I am. Day 18. Boiling boulders. Alliteration again. You and the elephants finally reach fresh air. You've emerged near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected towards you, so you're sheltering in the cavern exit a little longer. Outside the cave, you see the lava landing in a pond and hear it loudly hissing as it solidifies. Eric's a true writer. He should write a novel, to be honest. Depending on the specific compounds in the lava and speed at which it cools, it might be forming obsidian. Yeah, I just remember obsidian from Minecraft. The cooling rate should be based on the surface area of the lava droplets, so you take a quick scan of the droplet as it flies past you, your puzzle input. How utterly convenient. Quick scan of the lava droplet, not too bad. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result it approximates the shape of the lava droplet with 1x1x1 cubes on a 3D grid, each given its XYZ position. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only 2 adjacent cubes, like that and that, each cube would have a single side covered and 5 sides exposed, therefore a total surface area of 10 sides. Example. So what is the surface area of your scan lava droplet? Yeah, so I mean, when I opened the question, I was kind of surprised because at least on my monitor, you don't even need to scroll. Like, this is a really short question. So yeah, I mean, I just read the last line. I really just completely missed all of that. I just saw the bold statement, and then I kind of read this. Yeah, you didn't really need to read much of this, to be honest. I just read this. You really only needed to read this, and then I guess this, just to understand what how everything's going to work. But yeah, I think it's really quickly. I understood that really quick, and I think it shouldn't be too bad for most people to understand. Yeah, I mean, you're essentially counting the surface area of each cube, but cubes that are next to each other, the faces contradict each other, so you don't count those surface areas. I think that was pretty. I mean, I don't know. I really like coordinates, and I'm quite comfortable with using coordinates. I just love coordinate questions. But yeah, I think that's a pretty easy question to understand. And I was really happy with that. And yeah, just like that, my code's also pretty short. So taking the input, splitting on each line because each line's a coordinate, and basically the idea is for every 1x1 block, because each line's a 1x1 block. So and this is a really nice way of extracting the actual coordinate as integers. I like that. And for every 1x1 block, I'm taking it, and then I'm saying, okay, I'm going to look above this block, below this block. So the block has 6 faces, and therefore from the block, there are 6 directions you can go into. They can go up, down on the X, up, down on the Y, or up, down on the Z axes. All of those. And so there are 6 directions, 6 faces. And what you need to check is if in each of those directions, is there a block right above that? So if you have a cube, I have a cube here. If you have a cube like this, what you're doing is you're checking each of these directions, and you're checking if there's a block right there. So you need to check there's a block right above it, or right next to it. And if there is, then you don't add the face count. So what I'm doing is I'm counting the number of faces. T is just number of faces, and so you're basically checking if there is just an air gap above it, then the face is exposed, and therefore let's add that to my surface area. And the way I do that is by these loops. So this is like x-axis, this is y-axis, and this is z-axis. Effectively all the same thing, just in the different axes. And this checks 2 coordinates. This checks both directions of the x-axis, for example. You're checking the one below it, so one below it, and then you're checking the one above it, so one above it. But you don't want to check your current one, right? Yeah, I mean, wait, I'll get onto that. So now I'm looking both above. So I've got my blocks. Now I'm looking on one axis, just let's say the x for now. I'm looking above and I'm looking below. And now I'm saying here, if there was nothing above and below, then I'm going to add 1 to my face, because it means this face is exposed. There's nothing above, there's nothing below, this face is exposed. And you know, V is just a set of all the current cubes. But then, what if the face isn't exposed? So what if there's a block right on top of this? Then you need to ensure, not only are you not going to add 1, because the face is covered, you also need to remove 1, because before this block entered, you still had a cube here, and there's still a face underneath, which you counted for, which my code counts for. But now that I've added a block there, that face underneath, like, doesn't exist anymore. It's not part of the surface area. So that's why you need to minus that, as well as not adding 1. So I minus 1 which I added earlier, before this block was there. But to ensure I don't just randomly minus 1, I basically need to ensure that my my current coordinates are not the same block as my current one. So for example, what my code does is it goes through up and down. So my code does is it checks the up, the down, but it'll also like checks this block because it goes from the range of 1 below, the same one, and 1 above. But if it's obviously like the block, so I'm checking 3 coordinates, right? I'm checking the coordinate below, the coordinate above, but also to do those, I'm also checking, like unintentionally, the coordinates, which is the actual block. And so I'm checking if I am the actual block, then don't do this, right? So if I am the actual block, basically do nothing. There's a couple more logic points in here, you can probably delve into that. But yeah, that's pretty much it. Just go through every coordinate, every block, I guess. I'm checking the 6 directions, and as long as there's no block above it, I'm going to add 1. If there is a block above it, I'm going to minus 1 for my current face surface area total, and I just print the total. Yeah, so I think initially my error was probably not doing this, right? Yeah, because that's a pretty easy error to make, because it doesn't necessarily occur to you that you have to, like, once you've discovered there's a block here, it doesn't necessarily occur to you that you also need to minus the face which you've added before. But I mean, like, that occurred to me because, well, later on, because it said my answer's too high, so clearly I'm overcounting somewhere. And yeah, that was part 1, really nice and easy. Part 2, right. Oh yeah, and the runtime on that is pretty much instant. I'm not going to check it, but it was instant. Something seems off about your calculation. The cooling rate depends on the exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. It said consider only cube size that would be reached by water and steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. So what is the exterior surface area of an expanded lava droplet? Yeah, I mean, I kind of read this, and then all of this. To be honest, I shouldn't have read any of this, because this confused me a little, because there's like a bit of storyline here, but for part 1 I didn't actually read any of the storyline, so I had no idea what this was referring to. It's a bit confusing, to be honest. I ultimately think that was kind of my fault. It wasn't that confusing in retrospect, but I think I just really couldn't understand the problem, and the first like 45-50 minutes of me coding was just, am I even considering the problem correctly? But I mean, yeah, effectively it literally just wants this. That's a question, and like all of this just confused me. Yeah, that's ultimately the question. I kept having to flick back and see if I was correct, like my understanding of the question, and eventually I was, and eventually I got the correct answer. So let's check that out. Right, so here's my code. Again, because it was such a long process for me, there's lots of junk code in here, but it does print out the right answer, which is good. Right, so similar thing to before. Now what I do is I just keep track of, I mean, there's a lot of code here, so I'm not going to go over everything, but yeah, I'm not going to go over everything actually. So similar idea. So, you know, just like my code before, at this point, my set V, I have a set called V, and in V is every block that's occupied with lava. And then the next thing I want to do is I then turn all of these blocks into a what's it called? Into like a 3D array, right? So I have a 3D array called Z, or Z if you're American, which I'm sure probably most people here are. So I have a 3D array called Z, and then basically I'm basically just mapping my coordinates to the 3D array. So right now I have a set of coordinates, but I kind of want that into a full 3D array. So if there is a block of lava there, that coordinate in the 3D array is 1. If there's no block of lava, then it's 0. That's what that bit does. And then this bit, I think this was like a smart idea, which I eventually had, and this was like the idea that solved the problem. But yeah, it took a bit too long to find this idea. So it's just a BFS. I love my BFS. It's like the 7th time I've coded a BFS in AoC this year, and there's still another week to go. But yeah, it's a BFS, and I guess you can ignore that line. But essentially, what I'm doing is I'm starting at just the top left corner of my 3D grid, my 3D array, and I'm basically simulating water. So I'm saying my water source, let's just say it's right at the beginning right here, that's my water source, and now I'm using a BFS to see everywhere my water source can go to. So every block my water source can reach. And I think that's a really smart use of a BFS, because it's not really a graph, but I'm kind of turning it into a graph. I don't know, it's like I'm using the BFS graph algorithm to do a non-graph thing, which is just to see if I start up at this position, if my water starts there, so my water starts anywhere outside the lava essentially, which block's going to go to. And yeah, basically the idea behind that is any block the water can't go to is inside a lava droplet, and therefore I need to keep track of it. So what I'm going to do here is by the end of this, I want to get a set of all the coordinates that are not reachable by water. And if it's not reachable by water, it is either, well, if it's not reachable by water, it has to be empty air inside a block. And yeah, I just simulated the movement of water here. Yeah, I mean this 2 here is just the interval, just so I'm saying go down and go up. Like with my cube example earlier, I went down, same, up. What I'm doing here is I'm just skipping them same, I'm just going down and then up. I only thought of this idea later on in part 2, and that's why it's not my part 1 code. But yeah. So essentially what this does is it finds everywhere the water can go by simulating the water starting position, which is anywhere outside lava, and I know for a fact this coordinate is outside lava because I made it. And then if it's outside lava, then yeah, just simulate everything. And at this point, I have a set where every I have a set of coordinates where the water can reach. So then what I do is all of this really is just converting those coordinates and using the set dot difference, like this idea, this command, to find out. Okay, so out of every possible coordinate in my grid, I'm now looking at every coordinate the water can reach, and I'm finding the difference between them. So I'm basically inverting my set. So right now my set has, at this point, my set has every coordinate water can reach. All of this code basically just inverts that to say, okay, at this point, I now have a set for every coordinate water can't reach. And this is like the rest of the code. Everything below that you can kind of ignore. Yeah, this is the rest of the code. And so I've got a bit confused here because I thought that the only places that water cannot reach will be air, like gaps inside. But there's also like a scenario where you have like a whole clump of rock. So imagine if you had like a 3x3 grid within your 3D array. It's like 3 cells, a 3x3 grid, and all of that was lava. Then the center block is lava, but water can't reach that because it's ultimately still in a block of lava, right? So essentially, what my set actually is, it's not a set of everywhere that's inside, every piece of air that's inside lava. It's a set of everything that is inside lava, including lava. So if there's a lava block inside, surrounded by lava blocks, that lava block is still accounted for in my set. Because it's not reachable by water, right? Because it's surrounded by other lava blocks. That took me like 3 minutes to understand, 3 minutes to realize, because I thought there was some sort of bug. Probably more than that, like 5 to 10 minutes. I thought there was some sort of bug. Eventually I realized that yes, it's just lava. Took me too long. But yeah, just looking at the example input, looking at some of my debugging things, I figured out that was the case. And then, yeah, so basically what I established at this point, my logic was wrong, but what I do have is I have a set of everywhere the water's not reachable, which could be either lava or air. But the point is, I have a set of coordinates where every coordinate is surrounded by lava, and therefore it's useful, because I can just do a check here. I'm saying, okay, if my coordinate is actually lava, so if I'm lava within lava, then I don't care, I'm just going to continue. And so if my coordinate is air, then I do that. And yeah, similar idea to before again, I'm just checking. Right, so at this point, basically, I have a coordinate of air. This is my coordinate of air, let's say, and it's surrounded by lava by some sort, like it's in a bubble of lava. Like, if it's in a bubble of lava though, it may not be touching any lava, and I think that's like the hard bit of this problem, because you can have like a massive bubble of air within lava, but only like the exterior blocks of that bubble of air are touching the lava. Everything inside is still in the lava, but it's not touching the lava. And the way this algorithm works is I'm trying to find which interior air droplets are touching lava, and for every face of lava is touching, remove one from my original answer. So I kept my party code the same, so I still have my answer, which is called T. It's just a variable named T. So what I'm doing now is I'm going through every interior air block. I'm saying, okay, look above, below, left, right, front, back. Look at all 6 sides. And if any of those sides is in contact with the lava block, I know that I then have to -1 from my part A answer. Because that means if any of these interior air blocks are in contact with the lava block, that means that face is also going to be interior. But the question asks for exterior faces. So if it's an interior face, then I have to remove that from my surface area, and eventually once I've done all of that, I have my answer, which is just going to be, I mean, I could just do T minus equal to 1. Instead I just keep track of the number of interior faces. So Y is the number of interior faces, T is the number of overall faces. So to find the number of exterior faces, I do T minus Y. Yeah, sorry for the variable names, but yeah, that's what I do. And I don't know, I kind of glossed over the logic a little for this last bit, so maybe if you're struggling to understand what I really meant, yeah, think about it a bit more. You can also play around with my code. It's linked in the description down below, directed to a GitHub repo with all of my code for every day. But yeah, I think that's all I had to say. This was just some experiments, but this is the answer line essentially. This line is the answer line. And yeah, I think my runtime was pretty fast. Like, I was expecting a slow runtime. Yeah, I mean, that's pretty instant. I feel like yeah, it is instant, I would say, because the only time you lose within that runtime is really just printing, because printing is really inefficient in Python. And here I'm printing a ton of stuff. It's like Python is really using more of its time printing than it is actually computing something. If I use PyPy, yeah, it's still instant, so you can't really tell. But yeah, that was today's problem. I really love those. I love those. Like, as much struggle as I had with understanding part 2, as frustrating as it was, I love those problems. Like, unlike day 16 and 15, which I just struggled with anyway, I really like today's. I think I just like coordinates in general. I just love coordinate maths and coordinate programming. It's just so good, it's so fun. Lots of nested for loops though in this type of thing. You probably saw my code, tons of nested for loops. But yeah, I think, ooh, maybe this problem comes, I think my favorite problem was day 7. I think I'm gonna have to, nah, day 7 is Linux. It's always gonna be better. Okay, I think day 18 is now my new second favorite problem. Yeah, it's my second favorite problem. Loved it. Awesome. I mean, it was tough work on Sunday because I spent too long doing it, but it was a good Sunday. Thank you, Eric. Yeah, and this is a Kaiwan calendar. Got 36 stars, 72% the way there. Etching ever closer to Christmas. And yeah, my volcano is starting to build up more as well. I don't know, is that some... Oh, yeah, that's going to be like the pond. Or like the lake that the volcano lava is dripping into. Because it said in the question that a lot of it's dripping into a lake. Should we see what his should be? Yeah. Landing into a pond nearby. And this is going to be the pond. Anyway, check out the leaderboard. 3 minutes. What's the first guy? 1 minute. Man, this is a joke. This is fast. I'm just going to stop it there. I know the problem was easy and quite mathsy, but come on, like, what are these times there? They're insane. Incredible. Part 2 times 4.5 and 13. I mean, these guys are really fast. I mean, these guys are still pretty fast as well down here. I'm just wondering, like, it's even assuming they understood the question properly the first go and didn't doubt that understanding like me. How'd you code it that fast? They could have something prepared or something. I don't know. These people are smart. Yeah, fair enough. Good job to them though, because yeah, you have to be pretty good to have done that fast. And yeah, at least today it's been less of a today has more souls than yesterday, which is nice. At least people aren't giving up entirely, right? Because you see after like day 7, people just completely gave up and stopped doing the rest. Whereas after yesterday, at least people kept going on, which is good to see. But yeah, let's check out the private leaderboard. Okay, now the scores are getting really messed up. I need to order by stars. Yeah, 7 people have done all 36 stars so far. I mean, these two are really close. I reckon they're going to get it. I reckon Oliver with enough time is going to get it as well. Mr. Gwilt, what's he doing? He's on a holiday. Right, today's times. Oh, Aiden, 30 seconds off the leaderboard. For part 2. I guess he did to me there. Well, not me, because I took an hour. Yeah. But yeah. Good times. I've been out with gas for part 2 really fast. How do people do that? I need to talk to him for how he did part 2 so fast today. Yeah, but good job. Yeah, well done for him. So where would I mean, I took so long for part 2. Yeah, all of these people would have beaten me. Right, and positions. Yeah, leaderboard positions are basically static. At least the top 4 are. They probably will be. But yeah, that is it for today. That is day 18 of Advent of Code 2022. Awesome day. Hopefully you guys enjoy that too. Maybe you don't like recording as much as I do, but hopefully you enjoyed that. Hopefully you solved it. Hopefully if you didn't, I gave you some help. And thanks for tuning in. I'll see you tomorrow for day 19.